Hello, my name is Akshit Potuganti and my student ID is 251348333. This is my CA1 assignment for blockchain system and my presentation is about the blockchain based student certificate and reward tokens. This project demonstrates how blockchain technology can be applied in education and solve real problems such as fake certificates, lack of verification systems, and absence of transparent reward mechanisms. The system combines smart contracts, NFTs, and decentralized storage to create a secure and verifiable academic ecosystem. Here, this presentation is divided into six parts: introduction to blockchain and educate, and implementation of ERC-20 reward tokens, and IPFS based decentralized storage, and real world cases and critical appraisal of blockchain. Here, introduction. Blockchain is a distributed ledger system where data is stored across multiple nodes instead of a central database. According to the industry reports, blockchain reduces fraud risk significantly because records cannot be outlined once stored. Smart contracts are self-executing programs deployed on blockchain and they remove the need for intermediaries and ensure automation. In EduChain, I combine three components: ERC-20 tokens for rewards and ERC-721 for NFTs for certificates, IPFS for storage. The key idea is ERC-20 and the ERC-20 721. This combines reflects real-world blockchain systems. Here, in part 1, I created an ERC-20 token called Edu Reward Token EDU. Total supplies are 200 tokens and decimals 0 and meaning no factorial values. The decision to use 0 decimals was intentional to simulate a simple reward system where students receive all points. All 200 tokens were initially mixed to a deployer wallet and I distributed 50 EDU tokens each wallet into 4 student wallets. This represents the balanced distribution system. So mathematically 5 into 4 is equal to 200 tokens and 100% of supply distributed. And this shows the blockchain can use it to fair and transparent reward allocation. And here the token was developed using Solidity version 0.8.20 and Open Zeppelin standard contracts. Deployment steps included writing contract and compiling in Remix and connecting to MetaMask and deploying to Sepolia testnet, verifying an Etherscan. Each transaction requires gas fees and event on testnet, which highlights the real cost blockchain operations. And the contract address and transaction has are publicly available and ensuring transparency. And we can see here the workflow of the deployment. First, the contract is written on the remix and it is compiled successfully through EduReward and it will be connected to MetaMask and deployed to Sepolia testnet and getting after copying the address of the deployment testnet, we will scan on if Sepolia Etherscan and verifying on Sepolia Etherscan. And here these are the evidence of the transactions. After deployments, the tokens are transferred to student wallets. Each student wallet is received 50 EDU tokens and verification was done using the balance of in Remix, Etherscan transaction logs, and this ensures accuracy of transfers and transparency of distribution. In total, 4 transactions are executed here, all are successful and all recorded on blockchain. This demonstrates how blockchain removes ambiguity in financial transactions. Here we have seen that total EDU tokens were distributed. And from here In part 2, I implemented NFT based certificates. The contract is certificate NFT uses ERC-721 for standard. Here, unlike ERC-20, EDU token NFTs are unique and non-interchangeable. I minted 4 NFTs, one per student, and each includes token ID, ownership address, and metadata link. This ensures that each certificate is unique and verifiable and permanently stored. And this is the NFT ownership was verified using ownership of token and token URL. For example, token 0 is owned by a student wallet. The confirms ownership is immutable. No duplication is possible. Unlike traditional certificates these NFTs cannot be forgot or altered. Here, IPFS storage and Pianata. Blockchain is not suitable for storing large files due to cost. So I used IPFS interplanetary file system via Pianata. So the process is certificate images are uploaded, metadata JSON created, and metadata stored on IPFS, and NFT links to metadata. Example here, name of the certificate and description course image. This creates a chain like NFT to metadata and metadata to image. IPFS ensures decentralized storage and permanent availability, no central server dependency. And this is the image which was I uploaded, and this is the link for metadata JSON, and it will get NFT token URL once we have uploaded, and this is the JSON file of the metadata certificate. And this is the Etherscan proof which I was copied my address. All activities are verified on Sefolia Etherscan. We can see contract deployment, transaction hashes, and confirmation status. For example, deployment transaction, mint transaction, and token transfers. This ensures full transparency and auditability. And these are the use cases. Blockchain has multiple real world applications like education. Education is for NFT certificates, eliminate fake degrees. And in finance, ERC-20 tokens power DeFi platforms handling billions in transaction. In healthcare, blockchain ensure secure medical records. And in supply chain, it tracks goods from origin to delivery. These use cases show that blockchain is not just theoretical but actively used in industries. Here, this is the critical appraisal. So, despite its advantages, blockchain has challenges like scalability, gas fees, privacy, regulation, legacy integration, and immunity trade-off. Let's see one of. Scalability. Network slowdown under heavy usage. Here, gas fees. Even small transaction cost more money. In privacy, public data conflicts with GDPR. In regulation, unclear legal frameworks. Integration, difficult with existing systems. And immunity, mistakes cannot be reversed. For example, if a wrong certificate link is stored, it requires a new transaction to fix. So, these are the key learnings and outcomes. First, we have deployed the ERC-20 and 200 EDU are minted and 50 tokens were distributed to each student wallets and all are verified on Sefolia. And ERC-721. Here ERC-721 deployed and 4 unique education certificate NFTs are minted and ownership verified via owner of directly on chain. And here IPFS integration, certificate images and metadata JSON pinned via Pianata, token URL links each NFT to off-chain IPFS assets and real-world relevance. Blockchain credential reduce fraud, improve portability and audit trails across education, finance, healthcare, and supply chain. Here, honest limitations, gas fees, privacy trade-offs, immutability, risk and legacy integration remain real barriers to production deployment. And thank you for listening. This concludes my presentation. I am happy to answer any questions. Thank you. Thank you so much.